This is Arjun. In today's session, we'll see how to solve the problems on stress concentration using ANSYS. There is a given problem. For the figure shown, determine the maximum stress induced, taking stress concentration factor as 2.5 and Young's modulus is 200 GPa, Poisson's ratio 0.3, thickness of the material given is 10 mm and width is 50 mm by 80 mm. Width and depth are 50 mm by 80 mm. This is 80 mm. Okay, now we'll see how to solve this problem using ANSYS. I am using ANSYS 14.0 version. First, I'll go to Preferences. I'll select Structural Analysis. Click on OK. Then go to Preprocessor, Element Type, Add Element. So again, click on Add. Here you can see solid elements. So we need to create a solid rectangular block and then drill a hole in mid of that black. So I'll select solid element, click on OK. So now that solid element will be seen here, and here we need to go with a plane stress condition. So I'll go to options. We have something called as options. Click on options. See here we will see element behavior is plane stress. So we need to select plane stress with thickness. Okay, because we need to specify the thickness of that solid block. So I'll select plane stress with thickness, click on OK. Then you can close this. Then you can directly go to material real constants. So here we need to add that function whatever is that we have selected in plane stress with thickness. Add. So now that whatever the element selected will be displayed here, click on OK. So now it will ask for real constant set number and thickness function. Thickness value we have to be entered here. So that thickness value is 10. We will enter 10. Click on OK. See now that set is displayed here. Then we can close this. Go to material properties, material models, structural, linear, elastic, isotropic. So now entering modulus as 200 GPa, 200 e power 3 with Poisson's ratio 0.3. Click on OK. That materials will be displayed here. Close it. Then go to modeling, create. So here we need to create an area. So I'll go to areas. So first I need to create a rectangle of dimension 80 into 50. So you can create rectangle using any of these options, by two corners, by center and corner, or by dimensions. It is very easy to create an object by using dimension. So I'll select by dimension. So you can enter the coordinates for this. So x dimension is 80. So initial point is 0 and total dimension is 80, and in y coordinate it is 0, 50. So you can select two peak points, click on OK. So you can see now a rectangle with 80 by 50 is created. So now what we have to do is we need to create a circle at midpoint of this slab. Okay, so what we do is I'll go to circle. I need to create a solid circle. So I'll create a solid circle. Now see that solid circle has to be created exactly at this midpoint. Now since this total dimension is from here to here, it is 80 mm. At midpoint it will become 40. So I'll select x distance is 40 and y distance, working plane y distance is, so this total distance is 50 from here to here. So at this point it will become 25. So I'll select 25 and total diameter is 10 mm. So radius of that circle will be 5. I'll select 5. Click on OK. So you can see a white circle. Okay, a solid circle has been created now. See, what we have to do is we need to drill hole at this solid circle. So again, so close. If we go to operate, so we have a command called as booleans. Go to booleans. So here we have different commands: intersect, add, divide, glue, subtract. So we need to subtract this circle So I'll select subtract. Okay, what we need to subtract, since we have created areas, we have to subtract area only. So I'll select area. So you can see in this command menu, pick or enter base areas from which to subtract. This is a base area. Okay, so now I'll select this rectangle. See, it says there are 2 areas at this location, picked area is 1. So that is a base area. So just click on OK and then click on apply. Okay, now that base area is selected. See, again, pick or enter areas to be subtracted. Now we need to subtract this circle only. So you can select like this. See, now it is saying there are 2 areas at this location, picked area is 1. So we don't want to subtract the rectangle, we need to subtract the circle. So just click on next. So now you can see the pink color is highlighted only on the circle. Now it is saying picked area is 2. So now we need to subtract this picked area. So I'll just click on OK. Then you can click on OK. Now you can see this area is subtracted. Okay. Now after modeling, we need to mesh this object. Go to meshing, mesh tool. So since we have created areas, so in my previous videos you would have seen say in beams, so we have created lines and then we will be setting lines. So since we have created area here, so we need to set the area. I'll set area. You can directly select from this, click on OK. So element edge length has to be 1 because the mesh size has to be very small here. Okay, element edge length is 1. Click on OK, and now it is not meshed. Again, go to mesh tool, mesh. Okay, select pick all. Okay, it will take some seconds to be meshed. Close this. Okay, now it is totally meshed. This object is meshed. Now we can start applying loads. Go to loads. Okay, apply, define loads, apply. Structural, so since we are doing structural analysis, displacement. So now you have to be very careful. The loading is on these 2 directions, but if you don't put constraints on these elements, so it will be displaced. That effect of load will not be there. So what we have to do is, we'll select this lines. Okay, on the lines, I'll select this line. I'll fix this line in X direction. The displacement will be fixed in X direction, so that what happens when you apply load in this direction, so this will not be displaced. Okay, apply. So and similarly I'll select this line and apply displacement in Y direction. It should not move up and down, so you can observe here. And now since the load is 10 kilonewton, since it is a solid member, you cannot apply load. The load will now, because since we'll have certain area for a solid, it will become pressure. So we have to calculate the pressure. You can refer my analytical solution for calculating pressure. And now I'll go to pressure on line again. So I'll select this and this because the load is acting over this region and the pressure will be acted on this particular areas. So that is the reason why I selected. Apply, and since on calculation the pressure happens to be -20, and since the load is acting away, so I'll take it as -20. If the load is acting towards the member, take it as plus. Okay, so click on OK. So you can observe here, so if the load is acting away, so I have taken it as -20. And now we can solve the problem. All the parameters are given. Solution, solve, current LS. Okay, the problem is solved. We need to view for maximum stress obtained. So I'll go to general post processor, plot results, contour plot, nodal solution. Here you can go to stress. In the stress, if you scroll down, you can see Van Messes stress. So because it is a plane stress problem, we'll go with Van Messes theory. So now this is a stressed region, and the value obtained, maximum stress obtained is 60.5. You can cross check this with the analytical solution obtained, and this is the region of maximum stress concentration, the one which is indicated in red color. Thank you.